Hello, I'm going to explain about AC motor. An AC motor is an electrical motor driven by an alternating current. The AC motor commonly consists of two basic parts: an outside stator having coils supplied with alternating current to produce a rotating magnetic field, and an inside rotor attached to the output shaft, producing a second rotating magnetic field. The rotor magnet field may be produced by permanent magnets, reluctant saline C, or DC or AC electrical windings. Less common, AC linear motors operate on similar principle as rotating motors but have their stationary and moving parts arranged in a straight line configuration, producing linear motion instead of rotation. The two main types of AC motors are induction motors and synchronous motors. The induction motors are also known as asynchronous motor, always relies on a small difference in speed between the stator rotating magnetic field and the rotor shaft speed called slip to induce rotor current in the rotor AC winding. As a result, the induction motor cannot produce torque near synchronous speed, where induction or slip is irrelevant or cease to exist. In contrast, the synchronous motor doesn't rely on slip induction for operating and use either permanent magnets, salient poles, or an independent excited rotor winding. The synchronous motor produces its rated torque at exactly synchronous speed. The brushless wound rotor doubly fed synchronous motor system has an independently excited rotor winding that doesn't rely on the principles of slip induction of current. The brushless wound rotor doubly fed motor is a synchronous motor that can function exactly at the supply frequency or to super multiple of the supply frequency. Next, I'm going to explain how the AC motor are controlled. The speed of AC motor is controlled by changing the frequency of electrical supplies to the motor. The three-phase voltage in the national electrical grid connected to AC motor creates a rotating magnetic field in it. Lastly, AC motor is widely used in heavy industrial and household environment. This is due to low cost and high efficiency mechanism. That's all. Thank you.
Hello everyone. Okay, so we move to our next topic, which is brushless DC motor. Okay, do you know that what is brushless DC motor? So brushless DC motor is a type of motor which is known as electronically commutated motors or synchronous DC motors. So it is used because it can produce high amount of torque, so it can be consumed as highly efficient in terms of DC motor. Okay, so there are two types of brushless DC motor, which is the first one is inner rotor design and the second one is the outer rotor design. So for the inner rotor design, the design is the rotor is located in the center of the motor and it is surrounded by the stator winding. Because the rotor is located at the center of the motor, so the rotor magnets do not insulate heat inside and the heat get dissipated easily. So because of that, it will produce a large amount of torque. Okay, for the second one, which is the outer rotor design, the stator winding is located at the center of the motor and it being surrounded by the rotor magnet. Magnets of the rotor trap heat of motor and do not allow to dissipate the heat from the motor to the outside. So as a consequences, it operates at lower rated current and has low clogging torque. So how do brushless DC motor work? Okay, first foremost, we should know that brushless DC motor has two basic part, which is the rotor part and the stator part. For the rotor part, it contains rotomagnet, which will remain rotating during the process. And for the stator part, it contains the stator winding. And during the process, the stator winding should be permanently static. Okay. So then the two basic part is connected to a computer, which is connected to high power transistors that are be used to charge up the electromagnets as the shaft turns. Okay, brushless DC motors are controlled by controlling the rotation of the shaft. Okay, how we maintain the rotation of the shaft? Okay, the rotation is achieved by controlling the magnetic fields generated by the coils of the rotor. We know that the rotor is connected to wire and electric, so that will create the magnetic field. At the same time, the magnetic field generated by the permanent magnet from the magnet is fixed. Okay, to change the rotation speed, we should control the voltage of the coil by adjusting the magnitude and the direction of current into the coil. So from there we could change the rotation and we can change the magnetic field generated by the coils.
There are some comparisons between AC motor and DC motor. Firstly, AC motors are powered from alternating current AC, and DC motors are powered from direct current that are, for example, batteries and the other direct current sources. And then AC induction motor do not use brushes, while DC use brushes and a commutator, which limit the speed and usually reduce the life expectancy of brush motors. Okay, the next comparison is about the speed. AC motors speed is controlled by varying the frequency using an adjustable variable frequency drive control, while in DC motor speed is controlled by varying the armature uh, windings current. And is actually the application of DC motor and AC motor is still alive in our daily life. It's not like DC motor has been banned or has been thrown out from our daily industry. So um, the first is about the application of AC motor. So, what are the applications of AC motor, and what are the applications of DC motor? DC motor. So, the applications of AC motor is, firstly, AC motor can be found in numerous home appliance and applications, including clocks, power tools, disk drives, washing machines, and other home appliances. And then it also used in audio turntables and fans. They can also be found in industrial applications such as pumps, blowers, conveyors, and big compressors. And for DC motors, usually DC motors is used in um, small motors usage, such as first is tools, toys, and the other home appliance also use DC motor, which use lightweight brush motor for portable power tools. And larger DC motors are used in propulsion of electric vehicles, elevator and hoist, or in drives for steel rolling mills. The advent of power electronics has made replacements of DC motors with AC motors possible in many applications. So basically, um, before AC motors were invented, DC motors are widely used in even big industry. But then it is changed into AC motors because of the more advantages from the AC motors. Thank you. So now we talk about the general comparisons between DC motors and AC motors. So for DC motors, they have the advantage of first is DC motors have higher starting torque. The second one is DC motors have quick starting and stopping. Next one is DC motors can be reversing, and then DC motors has variable speeds with voltage input, and they are easier and cheaper to control compared to AC. But then AC motor have advantages including first the lower power demand on start and minimal maintenance, while the market for AC motors, the second one is the market for AC motors is larger than DC, mean it is easier and more available than DC. And then the third one is uh, it can be challenging to find AC solutions with fractional horsepower ratings. Okay, thank you.